Hello students. So continuing with the previous video that we saw of theorems, we'll continue with few more theorems. So I have already written down the theorems, few more important theorems. Inscribed angle theorem. So what does the inscribed angle theorem states? The measure of an inscribed angle is half of the measure of the intercepted arc. Now what do you mean by an inscribed angle? If you draw a circle and if you draw an angle with the vertex on the circle, then it's going to be an inscribed angle. But to prove here, what we'll do is we will take one of the arms on the diameter to prove the inscribed angle theorem. So ABC, so given angle ABC is the inscribed angle. Inscribed angle because its vertex is, the circle is lying in the circle and the vertex is on the circle, so it's an inscribed angle. Intercepted arc, the part which this angle cuts, the part of that arc, that is called as the intercepted arc. So over here angle ABC is the inscribed angle which intercepts the arc AXC. Therefore AXC is the intercepted arc. So we have to prove that the measure of the inscribed angle, that is measure angle ABC, is half the measure of the intercepted arc, means half measure arc AXC. Now there are three possibilities: that one of the arms of the inscribed angle is on the diameter, or it is in the minor arc, or in the major arc. So we'll see the basic one, that is where BC, one of the arm, is on the diameter. So prove case 1, and this will mostly asked if it's asked in the exam. One of the arm of angle ABC, that is BC, is the diameter of the circle. Is the diameter of the circle. Now let's take this as a midpoint, Y as a midpoint, and let's join OA. O is midpoint, AO is the center of the circle, center of circle, join OA. So first step, measure angle AOC will be equal to measure arc OBA, measure angle OBA plus measure angle BAO, because this angle will be this angle plus this angle. That is a property of remote interior angle theorem. A remote interior angle theorem, that is this angle will be equal to this plus this angle. That's the first step. Next, second, now OA is equal to OB, radii of same circle, radii of same circle. Therefore can I say OBA, measure angle OBA, measure angle OBA will be equal to measure angle BAO. Oh, suppose let's consider it with some letters, say P. Reason, as these two sides are equal, it's an isosceles triangle, so the angles opposite to these sides are equal. Isosceles triangle theorem, so they should be equal. So if this is P, This should also be P. Fourth step. Now, so therefore, what can we write this as? Measure angle AOC will be equal to measure angle OBA is P and BAO is also P, that is equal to 2P. Okay. So, now measure angle AOC. Next step. Measure angle AOC is actually equal to measure arc AXC. That is the definition of central angle. Definition of central angle, that whatever this central angle is, the arc is of that same value, same measure. So instead of writing measure angle AOC, I can write it as measure arc AXC will be equal to twice, and instead of P, can I write it as measure angle OBA, because P is same as OBA or BAO, so I'm writing as this. From which steps are this? From statement number 3, I am, instead of writing P, I am using OBA, and from this statement number 4 and 5, from 4 I know measure angle AOC is equal to measure arc AXC, so instead of AOC I have written AXC. So from statement number 3, 4 and 5 I can write this. No, but measure arc AXC twice, is measure angle OBA same as measure angle ABC? See, measure angle OBA is this angle and measure angle ABC is also the same angle, though basically it's same angle with different name. So hence, therefore 2 will come this side, so half, it will become come in division, half measure arc AXC is equal to measure angle ABC. Proved. You can check out, that was what we had to prove. Measure angle ABC is half of measure arc AXC. So that is the inscribed angle theorem. That's how we'll prove it. Next one, an exterior angle of a cyclic quadrilateral. Now what's a cyclic quadrilateral? A quadrilateral which has all its vertices touching the circle, it's called as a cyclic quadrilateral. So let's name the cyclic quadrilateral ABCD. So this is a cyclic quadrilateral. So given quadrilateral ABCD is a cyclic quadrilateral. Now we have to prove, and let's extend this at say point E, and angle DCE. Angle DCE is the exterior angle of the cyclic quadrilateral. So what we need to prove in this theorem is, let's read the question. An exterior angle, that is measure angle DCE, is equal to angle opposite to the adjacent interior angle. Now which is the adjacent interior angle? This would be the adjacent interior angle, and the opposite to this is this angle, so it will be equal to measure angle BAD. So this is a property that the exterior angle is equal to the adjacent angle opposite to the adjacent interior angle. So this is what we have to prove. So how do we prove it? It's a 3 steps proof, simple proof. First property is going to be, so number 1, measure angle BAD plus measure angle BCD should be equal to 180 degrees. That's a property of cyclic quadrilateral. Property of cyclic quadrilateral. Second, measure angle BCD plus measure angle DCE should be equal to this angle plus this angle, should be equal to 180 degrees. Linear pair axiom, they form a linear pair. Angle DCB and angle DCE form a linear pair. So from statement number 1 and 2, what we can say is measure angle BCD plus measure angle DC, this is also 180, this is also 180, so we can write it is equal to measure angle BAD plus measure angle BCD. Is a property of transitivity. 1 is equal to 2, 3 is equal to 2, so which is equal, we leave it, and we can say the rest of the thing, BCD plus measure angle DCE should be equal to BAD plus BCD from statement number 1 and 2. Now see, both have BCD on both sides, so we can just remove it, cancel it, because it will be same. Therefore measure angle DCE will be equal to measure angle BAD. That's what we needed to prove. Proved. 3-step proof, but an important proof. 5th proof is that opposite angles of a cyclic quadrilateral form supplementary angles. Supplementary angles. So again, let's draw the diagram. So the diagram is going to be something like this. There is this cyclic quadrilateral, means all its vertices are on the circle. So given thing is quadrilateral ABCD is a cyclic quadrilateral. Cyclic quadrilateral, we have to prove number 1, opposite angles, means this angle and this angle. Measure angle BAD plus measure angle BCD should be 180 degrees. And second one, this one's measure angle ABC plus measure angle ADC should be equal to 180 degrees. So this is what we need to prove. How will we prove it? Let's write down the proof. So in the first case, first thing, inscribed angle BAD, inscribed angle BAD intercepts, where is it intercepting? This much arc, intercepts arc BCD. Therefore what we can say is measure angle BAD, this angle should be half of this arc. Just now we saw the inscribed angle theorem is half of measure arc BCD, inscribed angle theorem. Inscribed angle theorem. Second step, again the same thing. This time inscribed angle, let's consider this as the inscribed angle BCD. Inscribed angle BCD, angle BCD, now where does it intercept? You just extend it, you will come to know it is intercepting this much arc. Angle BCD intercepts arc BAD. So therefore we can say measure angle BCD should be half of measure arc, which part is it in intercepting? Measure arc BAD, inscribed angle theorem. Inscribed angle theorem, add 1 and 2 step, add 1 and 2. So what I'm going to get is measure angle BAD plus measure angle BCD should be half of measure arc BCD plus half of measure arc BAD. Now half is common, so we can take that out common. Measure arc BCD plus measure arc BAD. This is the most important theorem. They always ask this theorem in the exam. Half into, now you check it out, BCD means this much arc and BAD means this arc, means it becomes a total circle. Now the total circle measure is 360 degrees. Total circle is equal to 360 degrees. So two 180s are. Therefore what we can say is measure angle BAD plus measure angle BCD will be equal to 180 degrees. Proved. That's the first one we have to prove. Similarly, you don't have to do the same thing again. You just have to write similarly we can prove the second statement, that is measure angle ABC plus measure angle ADC is equal to 180 degrees. Just for your information, if we had to prove this angle plus this angle is 180, again the same way you would have done it, that measure angle ABC will be half of this arc, measure angle ADC would be half of this arc, just add both of them, so it would be the circle. So 360, half into 360, 180. Exactly the same way you have to write it. Okay, so this is how we'll prove this very important theorem, that is opposite angles of a cyclic quadrilateral form supplementary pair. One last theorem, very simple theorem, but it's asked in the exam, so just see it quickly. Tangents drawn from an external point are equal. What I mean is, there's a circle. The circle has a center, say O. There's this point P from where two tangents, these are from an external point, two tangents drawn, PA and PB. So given is segment P O is the center of circle, and segment PA and segment PB are tangents to the circle, from external point P. So we have to prove, what is the proof? That they are equal, means we have to prove that PA is equal to PB. So how do we prove it? Very simple proof. Just join this OA and OB, join OA, OB and OP. Now first of all, first statement, see segment OA is the radius and segment PA is tangent. Therefore measure angle OAP is equal to 90 degrees. That's again a theorem, that at the point of contact of a radius and a tangent, the angle made is 90 degrees. The theorem is tangent perpendicularity theorem. Same way, same thing. Segment OB is the radius. And segment PB is tangent. Therefore measure angle OBP 90 degrees. Again the same reason, tangent perpendicularity theorem. Now let's consider triangle OAP and triangle OBP. Let's rub this off. Consider triangle OAP and OBP. So what can we say is, first statement is going to be measure angle OAP is equal to measure angle OBP is equal to 90 degrees from statement number 1 and 2. From 1 and 2. Next is hypotenuse OP, or we'll just write segment OP is congruent to segment PO. Common side, this triangle also has this side and this triangle also have this side. Common side. And segment OAP we are considering first. Segment OA is congruent to segment OB, radii of same circle. Both are radius of the same circle, so they should be equal. Radii of same circle. Therefore, as the hypotenuse and one of the sides is congruent, therefore triangle OAP is congruent to triangle OBP by hypotenuse side theorem. Hypotenuse side theorem. Okay, so all the tests we have done in another video. You can check out that video in which we have seen all the congruency tests and how to prove it. Okay, so over here, as the hypotenuse is congruent and one of the side is congruent, therefore the triangles are congruent by hypotenuse side theorem, and therefore segment AP is congruent to segment BP. CSCT, corresponding sides of congruent triangles, and that is what we needed to prove. Therefore PA is equal to PB, proved. Okay, so these are the next set of few important theorems in your exams. You just seeing it is not enough. You need to practice also 1 or 2 times, and I'm confident that you will be able to do it. These are compulsory questions, so you should practice it 1 or 2 times so that you become fluent with it. And so these are the next set of important theorems. I hope you have understood, and thank you for watching the video.